Have you ever seen a magnet do something that looks like pure magic? It can zip a paper clip across a table, stick to your fridge door without any glue, and sometimes, when you put two magnets together, they just refuse to stick. They push away with this weird, invisible force. How can the same object both pull and push? Well, to solve this mystery, we're going to think like scientists. We'll look for patterns, test some simple ideas, and build the explanation step by step. Ready? Let's dive in. First off, what does a magnet actually pull? You've probably noticed it won't pull everything. It ignores a piece of paper, a wooden spoon, or a plastic toy. But it loves to grab onto things made of iron and steel, and many other metals that contain iron. So, right away, we know magnets are picky. This is our first big clue. Magnets aren't sticky like glue. Glue sticks to almost anything. A magnet only pulls certain special materials. So what's the secret? Scientists say a magnet creates an invisible force field all around it. This is called a magnetic field. Think of it like a bubble of influence. You can't see the field itself, but you can definitely see what it does. It's a bit like the wind. You can't see the wind, but you can see leaves dancing in the air. You can't see a magnetic field, but you can see a paper clip suddenly jump towards a magnet. So, in a way, magnets are like tiny winemakers, but only for certain metals. Now, here's where it gets even cooler. Have you ever picked up a paper clip with a magnet, and then that paper clip could pick up another one? How does that work? Imagine a magnet touches a paper clip. The clip zips up and sticks. Now, if you bring a second paper clip close to the first one, sometimes it also sticks, hanging from the first one like a chain. The magnet never even touched that second clip, but it still moved. This means the first paper clip actually changed. For a little while, it became a magnet itself. This is called magnetizing. So what's happening inside the metal? Well, inside materials like iron, there are countless tiny regions that act like mini magnets. They're way too small to see. Normally, these mini magnets are all pointing in random directions up, down, left, right in because they're all jumbled. Their forces cancel each other out. That's why a regular paper clip isn't magnetic on its own. But when you bring a strong magnet nearby, its powerful field gets all those tiny mini magnets to line up, like a huge crowd of people all turning to face the same direction. When enough of them line up, the entire piece of metal starts acting like a magnet. That's how one paper clip can temporarily become magnetic and pull another one. Okay, we're ready for the biggest mystery of all. Why do magnets sometimes push each other away? Every magnet has two special ends, called poles. One end is the North Pole, and the other is the South Pole. You can think of them as two different personalities for the magnet's ends. And there's one simple rule that never, ever fails. Opposites attract. A North Pole and a South Pole will always pull together. But likes repel. A North Pole will push away another North Pole, and a South Pole will push away another South Pole. That's why you can feel two magnets fighting each other in your hands. If you try to force two north ends together, it feels like there's an invisible spring between them, pushing them apart. So why do the poles behave like this? The simple picture is that invisible magnetic field lines flow out of one pole and loop around to enter the other. When you bring a North Pole near a South Pole, their field lines connect smoothly. It's like they're holding hands and they pull together. But when you bring two North Poles together, their field lines are both trying to flow outwards in the same direction. They crash into each other and push apart. It's like they're arguing and want their own space. You don't need to see these lines to know the rule works. The magnets prove it every time. Now for a mind-blowing twist. Our entire planet, Earth, acts like a giant magnet. That sounds crazy, but it's the reason compasses work. A compass is just a tiny, lightweight magnet balanced on a pivot so it can spin freely. When you hold a compass flat, the needle always turns to point in the same direction. It's lining up with Earth's massive magnetic field. That's right, there's a huge magnetic field surrounding our planet like an invisible bubble. This field is super important. It helps protect us from some dangerous particles streaming from the sun. And for centuries, it has helped sailors and explorers navigate the globe. So, every time you play with a little magnet, you're holding a piece of the same fundamental force that wraps around our whole world. Let's put it all together. A magnet creates an invisible magnetic field. This field can pull on certain metals by making all the tiny mini magnets inside them line up. When they line up, the metal temporarily becomes a magnet too. Every magnet has a north and a south pole. Opposite poles attract, and similar poles repel. And our planet, Earth, is a gigantic magnet that makes compasses point north. Mystery solved. Now it's your turn to be the scientist. Here's a little challenge. Find 5 objects around your house. Maybe a coin, a spoon, a paper clip, a piece of aluminum foil, and a key. Before you test them with a magnet, make a prediction. Which ones do you think the magnet will pull? Then, test them out and sort them into 2 groups, magnetic and not magnetic. And for a bonus challenge, put a piece of paper on a table and place a paper clip on top of it. Now, slide a magnet underneath the table, right below the paper. Watch as the paper clip moves around, like it's alive. No strings, no glue, no touching. Just that invisible, incredible force doing its work. That's the real magic of magnets. It's not a trick. It's a fundamental force of nature you can't see, but you can prove it exists just by watching what moves. Thanks for exploring the amazing world of magnets with me today. If you enjoyed this video and want to solve more everyday mysteries, make sure to hit that subscribe button and ring the bell so you don't miss our next adventure. See you next time.